Hey, I'm going to be doing the flying wild scenario, which is a briefing on performance calculations for the Seminole. I'm going to do a trip outline. I'll go through the scenario. I'll be talking about the calculations for departure, cruise, single engine, rate of climb, single engine service ceiling, and start to talk about some of those considerations, and then the landing performance calculations. All right, I'm not going to read it to you, but basically we're going to be taking a trip to a area that's higher terrain, rolling hills and whatnot. I picked out a route, and then I'll show you that in a minute. But we'll be discussing the flight. We'll be discussing losing an engine during that, and performance calculations, how that'll affect us. All right, so I picked out this route, basically going from my home airport up to Pueblo, up in south of Colorado Springs, up in Denver. I picked it because of kind of a fun little area right through here. Kind of opens up a fun conversation for single engine stuff, and I'll be talking about some of the things involving that when we get into it. All right, taking off out of Falcon Field, we have a METAR over here on the left, and we don't need to copy this down. I've got it later on. Our destination, we're going to Pueblo. Here's the METAR and the TAF. All right, here we go. Performance calculations. This is our takeoff over 50-foot obstacle. We're going to use this weight for our takeoff right here. And we're going to input it right there on our performance chart. We're going to take the temperature that we got from Falcon. We're going to put it over there on the performance chart. We're going to take our pressure altitude. We're going to take, and this is kind of, it feels ridiculous for this chart, but we're going to take density altitude from Falcon, and then we're going to backwards compute it, taking taking the altimeter. I'm sorry, we're going to take the pressure altitude. We're going to use the altimeter setting, and we're going to find our pressure altitude, and then we're going to apply the temperature calculation over here on our chart, rather than just taking the density altitude. Sorry, I got confused for just a second. Rather than just taking density altitude, we're going to go ahead and do all the calculations to find pressure altitude, and then we're going to calculate our density altitude on the chart, essentially. So winds come into play for our landing distance over, or sorry, our takeoff distance over there. And basically we do this by entering the chart right here for our temperature, and then we're going to move up and find our pressure altitude, and this is going to give us our density altitude correction. Basically, we're going to move over to the weight, and then we're going to move over to the distance, and then that's going to give us our takeoff distance. So one of the other things I'd like to point out on this is this little fun shaded area right here. And basically what this essentially means is that if we lose our engine and we've done our calculations in this range, we will not expect to get our any type of climb whatsoever during our takeoff with the Seminole. So that's something we brief and be aware of if we were to lose an engine. All right, this is our takeoff ground roll. Same thing. We enter at the temperature. We move up to our pressure altitude, move over to weight, move down, then across to winds, and that gives us our ground roll. This is our accelerate stop distance. This is basically the speed that we can take this aircraft under the very specific configuration that's been given to us, so cow flaps open, paved level, runway, maximum braking, mixture full rich, and on a perfect day at sea level by a test pilot, get all the way up to that rotation speed, have our emergency, and then apply maximum braking. But these numbers, from what I understand, are always wildly off. So enter your temperature, come up to your pressure altitude, weight, and come down, find the wind, and that'll give you your accelerate stop distance. So, all right, some performance calculations. So the first thing we're going to think about, I got some temperatures aloft, I got a cruise altitude, and we're going to find out what kind of settings we're going to use. So we're going to want to use some lower RPMs if we can to reduce the noise and make us more comfortable. And basically, we don't have 65% available. We don't have 75% power available because we're at such a high altitude. So all we get is 55%, and that's going to put us at 2,200 RPMs and then 18.7 if you're able to input that precisely. And again, that gave us 55% power, so we're going to move on. We're going to find out at cruise what our range and what our reserve is. I'm sorry, no, what our range and what our endurance is. So at 55% power, it looks like we can go about 755 miles. We can take that over and we can find out our endurance. It should get us about 5 something, just a little bit over 5. All right, performance cruise, we're going to find our true air temperature or our true airspeed, our fuel burn. We're going to enter at temperature. We're going to move up to pressure, altitude. Then we're going to follow it across and we're going to find out where we fit at 55% power, which looks like we're off the chart there. So I just found the arc. It came down 156, something like that, which sounds about right, I would think. And then also at the top there, we can find out at 55% power what kind of cruise we're going to, or what kind of fuel burn we're going to be doing, depending on how we lean the aircraft. All right, so here's where we're going to start talking about losing an engine. So if we're flying along and lose an engine, we want to know what our single engine service ceiling is going to be. So first of all, we can find out for our takeoff, what kind of rate of climb can we get for our takeoff with one engine inoperative and our gear up. So first we're going to enter at temperature here. Same thing, pressure, altitude. Come across, find our weight, come down, looks like just under 100. Yeah, something like it looks like about 95. Feet per minute climb at this temperature and altitude. And then we're going to backwards plan on this chart as well to find our single engine service ceiling. So we know that single engine service ceiling is 50 feet per minute climb rate. We're going to come up to our weight, follow it across, and then we're going to find about what altitude that is. And that looks like it's about 2,200 feet, something like that. So we're going to take that in mind. 2,200 feet is our service ceiling, and then we're going to take that along and look at our route and see what that means. And here's where it's kind of fun. We plan going through this mountain pass here with, let's see, some pretty high mountains here and right here as well. And even down here at the lowest, I think it's like 8,000 feet. So one of the things that's going to happen is we're flying through here. We know that we cannot sustain level flight. So we're going to have some type of drift down as we're going through this flight. And knowing that even that at no point will the aircraft ever level out and sustain flight. If we got to get down to 2,200 feet and we're flying over terrain that's 7,000 feet through here, through the middle, we're going to be looking for a place to land. So there is no, oh, can we make it? So something that's good to know. All right, some landing performance stuff. Same things before. We're going to take our weight here, enter temperature, altitude, come all the way over here, and same things before. We find our landing distance. We also find our VREF as well, so it looks like about 69, something like that. So for the weight, that'll be our VREF if we're doing that, unless your company or school is assigning you a speed that they want you to always follow. All right, landing ground roll, no change here. We're just going to, same thing, temperature, pressure, altitude, all the way over, and that's where we end up. All right, I went over all these things, takeoff, cruise, performance planning, single engine considerations, single engine rate of climb, single engine service sailing, and landing calculations. So I hope that covered it. I got everything from the Seminole POH, so thank you very much.